Welcome to our today's class this particular evening, and I'm going to use a question here to explain something concerning formula and variation. There's a question here that I want us to actually do. This question came in 2004. It was in paper 2 and it was question number 23. So the question says three quantities P, Q, and R are such that P varies directly as the square of Q and inversely as the square root to R. So P varies directly as the square of Q and inversely as the square root of R. So I have been given three very important variables. So we have P, Q, and R. I've said this topic is called formula and variation. So formula and variation. And we are told that we have three variables, P, Q, and R. How are these three variables related? We are told that P, the first variable, varies directly as the square of Q. So P varies directly. That means they are opposite to each other. They face each other directly. That means P is varying directly as the square of Q. So when you relate P and Q, you'll find that P varies directly as the square of Q. And you're told inversely as the square root of R. P and Q are directly related if Q is squared. But P and R are inversely related if you have to actually get the square root of R. Now, to remove this sign of variation, you're going to say P is equal to a constant K. You can pick any letter of your choice. It can be K, M, N, or O. So P is equal to a constant K, then Q squared, then this is divided by the square root of R. So P, Q, and R are actually related. This is the equation that can actually relate them by having a constant K that replaces that sign of variation. Now we need to get the value of K, which is now our constant. You're told that P is 20, Q is 5, and R is 9. P, you see, we're told that P is 20 and R is 5, and you're told Q is 9. If I am not wrong, so you're told that P is 20, Q is 5, and R is 9. You're told to find P when Q is 7 and R is 25. Let's first get the value of the constant. So you come here and say P, which is 20, you just substitute these values into this equation. So 20 is equal to K multiplied by, so 20, the value of P is equal to K times Q squared. So that is actually going to be 9 squared. Then this is divided by, okay, square root of R, so the square root of 5. So square root of 5. So our Q is 9. So that is 9 squared to the square root of R is now the square root of R is now the square root of 5. So we have 20 is equal to 81 over square root of 5. Now, you see, you're supposed to put here a K because that's the one you're looking for. So 20 is equals to K times 9 squared because it was Q squared. Our Q is 9. So it's actually 9 squared. So it's going to be 20 is equals to K times 9 squared. And 9 squared is 81. So it will be 81K over root 5. So just say times root 5. Then at this point, you can also be able to have times root 5. This and this will disappear. So I just come here and have this root 5, this one, multiplied by 20. The answer must be equal to 81K. So divide by 81 and divide by 81. this will disappear. So our k is equal to, now that will be 20 root 5 over 81. Wow, so that translates into what? So you need to get the square root of 20 and then be able to have the answer. We should be able to actually work out that. So that means you're going to have this. Let me get a calculator. So the square root of 5 with the calculator, square root of 5, okay, square root of 5, that will be 2 points. So we have 20 times, so you're supposed to get the square root of 5, then times 20, not the square root of 20. So times 2.23 606. This is divided by 81, and that should give us k. So to get that answer, then I say times 20, and I divide this by 81. So I'll have my k as 0.552. Very good. So 55, then 2. That becomes my k. That becomes my k.